Hello, everyone. Welcome to the Kubernetes tutorials. We're going to talk in detail about Kubernetes. It will be a series of lectures. This is the first part, wherein we'll cover some fundamentals and some commands of Kubernetes. And again, same pattern we will follow in the next lecture. Some more commands and some more theory or concepts regarding Kubernetes. All right. So what are Kubernetes? If you think they are containers, then you're mistaken. They are not containers. So Kubernetes is we often abbreviate it as K8. We say K8, which is Kubernetes. So it's an open source. This is important. So earlier Google used to own it, but now Cloud Native Computing Foundation owns it. So it's an open source container orchestration platform. What does it mean is it gives you the infrastructure wherein you can deploy your containerized applications which run within the container. Okay, Kubernetes support for that. It helps in deployment, scaling, and everything. Management of containerized application. It provides the framework for managing the workloads, services, etc. So you don't have to do it, okay, in a cloud native environment. This is how a typical Kubernetes architecture looks like. As you can see, two main divisions. One is the control panel and multiple nodes. Okay. So as the name suggests, the control panel will have a lot of control functionality, management functionality. And each node will have its own functionality. So one node can have more than one pods. A node is nothing but a machine. It could be a virtual machine or a physical machine in which one or more pods run. Okay, and each pod can have multiple containerized applications. Let's see what are some details or what is the functionality of all these. Now keep in mind the diagram. If you look at it, one thing is very obvious, that every communication that goes in and out goes through API controller or the API component. Others have other functionalities, but they all talk to each other via API or the API controller. So that's the hub and spoke API pattern. That's what Kubernetes follow. We will talk about this hub and spoke API pattern later in the coming lectures, what it is. All right. So API server, this, as you see, it's a dotted line. It's a cloud controller manager. It's optional. That's why it's dotted. It is, if you have a cloud provider API, it's used for that manager. Then you have the control manager. We'll see what each one does. We have the etcd, which acts as the storage. We have the scheduler, which schedules the pods, make sure that the pods are created and are in the state in which you expect it to be. So what are nodes? Kubernetes, actually, the main purpose of Kubernetes is what? To help run or provide infrastructure where you can run your containerized applications. Where does those applications go? They go in the nodes. What are nodes? Nodes can be virtual or physical machines. Okay, so and each node can contain one or more pods. Each node is managed by the control panel and contains the services necessary to run the pod. Services in the sense, if it requires any software or anything running before it, it makes sure it is there. So typically you'll have several nodes in the cluster, but two main categories. There is master node and worker nodes. Master node is responsible for controlling and managing the Kubernetes cluster. It contains several components: the API server, the etcd, control manager, and scheduler. As we can see here, so this is the master node. This is the master node here, this entire thing. It contains all these services running inside it. Control manager, API service, scheduler, etcd, everything is running within the master node. And these are all worker nodes. Okay. So scheduler, what it does is it's responsible for placing the pods or a group of containers into worker nodes based on the resource requirements. Resource requirements, whatever software, a specific version of the software, some data, what you need. So that scheduler job is. Control manager enforces the desired state of the cluster by continuously monitoring the actual state and making sure if something is not in the right state or configured state, it will make it. Control manager, a good example that I read about it, it's like the thermostat in your house, right? Thermostat, you set the temperature, okay, I want 68 degrees or whatever X numbers, 68 degrees Fahrenheit. It continuously monitors. And the moment the temperature goes below or above 68, it takes the necessary action. It will either turn on the AC or turn on the heating system of the house. So that's what the control manager is. Now, there are various controllers, such as the replica set controller, deployment controllers, everything. There are different types of controllers. etcd is a distributed key value store used to store all the cluster information, all the configuration data of the applications of the pods. It's a primary data source wherein Kubernetes will pull the information out when it has to start the node or create a pod. Worker nodes are the actual nodes where your application is running. And then what is there in the worker node? In addition to pods, there is the kubelet. What is a kubelet? It runs as an agent on each worker node and communicates with the master node. So kubelet talks to the master node and it reports back the health of the node. It is responsible for ensuring that the containers are running in a pod. So it monitors continuously the pod, whether the container is running or not, and report its health back to the master. Container runtime Kubernetes supports various container runtimes, such as Docker, Vagrant, Podman, etc. A lot of container software which are there. Okay. The container runtime is responsible for executing the containers within the pods. Kubeproxy is used as a load balancing thing within the cluster. It maintains the network rules and forwards the traffic to the appropriate pods, because see, there are multiple pods, right? So whom the communication has to go to, each one is talking to the master node, each one is talking to the API server. Where should it go? Okay, so kubeproxy does that functionality. The basic unit, scheduling, everything around whatever we have discussed, all this is for what? For the pods. It's the basic scheduling unit in Kubernetes. One pod can contain one or more containers. So the hierarchy is, there is one master node which can contain one master node which contains all the services necessary for maintaining the Kubernetes. Multiple nodes. Each node, it has a kubelet and a proxy. In addition to it, it has pods. One pod can have more than one containerized application. And in a Kubernetes cluster, you can have multiple nodes, multiple worker nodes. And as you can see here, everybody is talking to the API server or through API server. Now, this much is for theory today. Let's get into action. What we do is install minikube, because on your laptops, in order to practice, you do this. You don't actually go ahead and install clusters and everything. So the command which you will use is this. What image you're going to pull depends upon the operating system of your laptop. I have a MacBook, so that's why I used Darwin, minikube Darwin. Kubernetes, when you go to the website and you try to say download Kubernetes, it will automatically detect the operating system and suggest which one to download, which version of minikube to download. And then there's a command called sudo install minikube Darwin. Okay, this is the command. And then we just start minikube start. Let's see it in action. Okay. And here, here it is. This is minikube start though. So here, the download command, it downloaded based on my OS, and then use the sudo command to install. And if you just give minikube, it gives you the various options that are available. And here, if you see, I gave somewhere here minikube start. Here, minikube start. So you have here minikube, it started. So the version, Kubernetes is not now available. And it starts everything. And in the end, if you see, verifying Kubernetes components, enabled add-ons, everything, and done. kubectl, that's the Kubernetes CLI command, is now configured to use minikube and default namespace. Okay, so kubectl is actually you use it for the commands. So if you get the pod info, that's the command kubectl get po -a. A also gives you the age or how long they have been running. So see here, you have multiple namespaces, the core DNS, the etcd that we discussed, that is the key value storage, API server, the control manager, everything got installed, the kube proxy, the scheduler, and the storage provisioner. I just wanted to show you guys the trick, one trick, a shortcut, which I've learned. An alias, I think alias syntax, if you do, it's here. It helps you save time in typing. That's why I'm showing it to you. So it's something like alias name is equal to value. So say for example, C is equal to clear. So if I go here, alias K is equal to kubectl K. ./k. Maybe it doesn't work here. I don't know. Yeah, it doesn't work on my laptop. But yeah, but if it works on yours, definitely go ahead and use it. Let's see if it works with. Nope, it's not working. But if it's working, go ahead and use it. So what we need to do, instead of typing kubectl all the time, okay, you can directly just say k and it should work. So see how kubectl works. Similarly, if the alias would have worked, you could have just typed k and it would have worked. Okay? But for some reason, it's not working. Probably I have to define it in my bash script or some other script, dot zhrc file, which is the default, or the bash profile, which is default for Windows environment. If you configure there, it works. I can show you again, hopefully debug it and show you in action next time. But this was all for today, and we'll continue the conversation and more commands and more concepts of Kubernetes in next lecture. Until then, thank you for listening. Thank you for your time. Bye.